Okay. To tell whether, oh, here, let's just, the heart, the pointy bit at the bottom is called the apex. So this part here is apex. And the part up here at the top, the wide part, is called the base. Okay. And that seems counterintuitive because, the base, that should be the bottom, right? But if you think about a pyramid, the base of the pyramid is the wide part and the apex is the pointy part. And so the heart is like an upside down pyramid. Kind of, not really. So the base is the wide part at the top and the apex is the pointy bit at the bottom. To tell if we're looking at the front of the heart, there's these blood vessels running across it right here. And those are the coronary arteries and veins. The heart is like anything else in your body. It needs blood to supply it too, because it's a muscle. It needs fuel to go. So it's got arteries and veins that supply and drain it. And so they cut diagonally across the front here. If you turn this around, there's nothing cutting nice and diagonally across. Okay? So these guys here, these are called the auricles, because some loons thought they looked like ears. I guess auricle. So we have a right auricle and a left auricle. And these are right where the atria are sitting. Okay? So right here is where the right atria is, and right here is where the left atria is. So right auricle, left auricle. So if we look at, here's right atria. Here's a blood vessel going into it from the bottom. I think that is inferior vena cava, right? Because it's coming from down from legs and stuff. And then there's one going down into it this way. Superior vena cava, yeah. So if we open this up, you can see here's the hole where inferior vena cava is. And then here's the black mark where superior vena cava is draining. So superior vena cava and inferior vena cava back here. If you notice when we chop this open, there's the really thin-walled right ventricle, and then the left ventricle with its really thick walls there. Everybody see it? So if we're in the right atria, where does the blood go to next? To the tricuspid valve, which is right here. Here's tricuspid valve. It looks like a butt crack. Tricuspid valve. And from the tricuspid valve, we go into the right ventricle. Right atria, tricuspid valve, right ventricle. After the right ventricle, where do we go? To the pulmonary valve. So pulmonary valve is actually on this half. If we remember that this was the right side, and this was left. When we turn this around, we've got right side over here. You can tell because we have thin walls. The left side over here, it has thick walls. And right in there, there's a valve, and that is the pulmonary valve. Pulmonary valve. And it's going into this vessel that's right here. And if we turn this, we put this back on, this vessel, it's kind of like the one right in the front of the heart, and it's going right in between the auricles. So if we look at the cat, if we look at the cadaver, you'll see the two auricles, and you'll see a vessel going right in between them, and that's the pulmonary trunk. Okay? So after pulmonary trunk, where do we go?
Pulmonary arteries.
The pulmonary arteries. On here, okay, pulmonary trunk, it splits. So here's one part of the split here. That's the left pulmonary artery. And then the right ones are over here on the other side. So here's right pulmonary artery. So left pulmonary artery, right pulmonary artery. From here, where does blood go?
To the lungs.
To the lungs, where what happens? It gets oxygenated, and then it goes where?
Pulmonary veins.
To the pulmonary veins, to the
right. No,
to
left.
the left atria, right? Left atria, not right. Goes to the left atria. So here we have left atria, and then you'll see there's 4 little dark dots, 4 little dark circles in there. Those are where the pulmonary veins are going. And the pulmonary veins, if we turn the heart around, because they go around the back, there's one set of them here, and then the other set of them are over here. So we have the left ones over here, left side, and the right ones over here. So we have right and left pulmonary veins to the right atria, through the bicuspid valve, into the left ventricle, through the aortic valve, right there. There we go. There's aortic. I'm so falling asleep. It's funny because I fell asleep in the hallway outside of class, before class. I was like asleep for like 20 minutes out there. And suddenly a door opened and closed, and I woke up. It was weird. I was sitting on the floor, like upright. It's horrible. Okay, aortic valve into the ascending aorta, right here. Ascending aorta. And then it curves around to the aortic arch, and then it starts to go down. Descending aorta, and then down in the abdomen it becomes dorsal aorta. From the aorta, where does the blood go generally?
To the body.
To the body, and then from the body, where does it go?
Inferior.
To the superior and inferior vena cavas, into the right atria, through the tricuspid valve, into the right ventricle, through the
Pulmonary
valve,
Pulmonary trunk.
into the pulmonary trunk, to the
Pulmonary arteries.
right and left pulmonary arteries, to the lungs, where it gets oxygenated, and then it goes to
Pulmonary veins.
right and left pulmonary veins, to the left atria, through the bicuspid valve, into the left ventricle, through the aortic valve, into the ascending aorta, and then the story starts all over again. Let's see, some more features I need to tell you about. These things here, they're actually stringy things. These are called the chordae tendineae, or if you're my research professor, you say chordae tendineae. Sounds really weird to me. The chordae tendineae. And they're attached to the valves, right? These 2 valves, did I tell you that they're called atrioventricular valves?
Yeah.
Our tricuspid valve and our bicuspid valve are our 2 atrioventricular valves. They're called atrioventricular because they're between an atria and a ventricle, right? So these are our atrioventricular valves. So the chordae tendineae attach to the atrioventricular valves, and then attach to these little muscles that I guess people think look like nipples because they're called papillary muscles. Papilla is word for nipple, whatever. Papillary muscles here. And what these guys do, they act to keep your valves closed when your heart is contracting or during systole. So they keep your valves closed during systole. And so if we think about which way the blood is flowing inside of our heart, right? As our heart's filling up during diastole, it's flowing in, well, we'll just focus on right side. It's flowing in through our vena cavas, into our right atria, then it flows through into our ventricle, right? Okay. When the heart contracts, we want that blood to get pushed out of the heart into either the lungs or out to the body, right? So what these guys do is that when the heart contracts, these contract, and they keep the valves in place so that the valve can't swing back open, so that blood doesn't go backwards. So these muscles contract and hold this valve shut flat, so it can't blow up backwards, because that would just be bad. Okay. So you need to know the function of these two things together. You need to know that they function to keep our valves in place during systole, or during systole. What is it called? Systole nowadays, I guess. Yeah. That makes sense?
So when do they open?
The valves?
Yeah.
They're open during diastole, or while the heart's relaxed. And we'll get to that, we'll do that later. So it's not totally important to know diastole and systole, but mostly know that the chordae tendineae and the papillary muscles keep our valves closed when the heart contracts. We can put it in layman's terms, I guess, if you want. The muscle that's lining the walls of these guys, it's called trabeculi carnae. Trabeculi carnae? I don't know why. It's just a muscle lining the walls. Let's see what else I need to tell you. Okay, so where does the blood on the right side of our heart go ultimately? It goes to the lungs, right? And the blood on our left side goes to our body, right? When you are a fetus, are your lungs functioning? No, right? Because you're not breathing air. So in a fetus, they do what we call a pulmonary bypass shunt, where you don't want to be sending a whole lot of blood to the lungs, because a fetus isn't using its lungs are still developing, so they're really fragile. So the fetal heart has two ways of keeping blood from going to the lungs. Okay? One of them is this thing, there's like a little donut-shaped thing inside here. It's actually going between the two atria. It's labeled number 54 on here, if you want to just take a picture of it later. And in a fetus, it's called the foramen ovale. And it's basically a hole going in between the two atria. And so what that does is as blood is filling the fetal right atria, instead of all of it going into the right ventricle, some of it just passes through the hole into the left atria to then go back out to the body of the fetus. And in a person that's been born, right, they take their first breath, that foramen ovale closes up, and it just becomes this structure called the fossa ovalis. The fossa ovalis. So this thing on this model is actually the fossa ovalis, but in a fetus, it was the foramen ovale. But sadly, not all blood that was here in a fetus makes it over to the left atria. Some of it goes into the right ventricle, and some of it goes into pulmonary trunk. But a fetal heart has another way of dealing with that. There's this little thing in a fetus, it's called the ductus arteriosum. And so it shunts blood or sends blood from the pulmonary trunk into the aorta to go out to the body. So in a fetus, it's called ductus arteriosum. And here on this model, it's called ligamentum arteriosum. It's just a little ligament now. Man, everybody's sleepy today.
But you said the ductus arteriosus sends blood from pulmonary trunk.
From pulmonary trunk to the aorta. So it's right in between the two of them. I'm watching everybody I'm like, that's what I want to do. So stop it. So on